Understanding radiation pollution, causes, effects, and solutions. Radiation pollution, what is commonplace in discussions about environmental issues, poses a significant threats to human health and ecosystems. It refers to a presence of harmful levels of ionizing radiation in the environment, which can stem from various sources, including natural events and human activities. As the world grapples with energy needs, technological expansion, and environmental protection, understanding radiation pollution is crucial for informed decision making and public health. What is radiation? Radiation is energy that travels through space in form of waves or particles. It can be classified into two broad categories: ionizing radiation and non-ionizing radiation. Ionizing radiation has enough energy to remove tightly bound electrons from atoms and can damage living tissue. Sources include cosmic rays, radon gas, radioactive isotopes, and X-rays. Non-ionizing radiation includes lower energy forms such as radio waves and microwaves. While they can cause harm at very high levels, they are generally deemed safer than their ionizing counterparts. So, sources of radiation pollution: natural sources. Cosmic radiation developed primarily from the sun and outer space. Cosmic rays constantly bombard the earth. Radon gas. This naturally occurring radioactive gas accumulates in homes and buildings, particularly in areas with high uranium content in the soil. Terrestrial radiation. Elements like uranium, thorium, and potassium-40 in the Earth's crust contribute to background radiation levels. Anthropogenic sources. Nuclear power plants. While these facilities are essential for energy generation in many countries, accidents, leaks, and improper waste management can lead to significant radiation pollution. Medical applications. The use of X-rays and radioactive isotope in medical diagnostic and treatment, while generally safe when handled correctly, can contribute to pollution when not properly managed. Industrial sources. Certain manufacturing process and operations involving radioactive materials can lead to localized radiation pollution, risking exposure for workers and surrounding communities. Nuclear testing and warfare. Past nuclear tests and the use of nuclear weapons have left a legacy of radioactive contamination in affected areas. Effects of radiation pollution. Consequences of radiation pollution are profound and wide-reaching. Human health. Exposure to ionizing radiation can lead to various health issues, including acute radiation syndrome. High doses received in a short time can result in symptoms ranging from nausea to organ failure. Cancer. Long-term exposure increases the risk of developing cancers, particularly leukemia, thyroid cancer, solid tumors. Genetic mutations. Ionizing radiation can damage DNA, potentially leading to hereditary issues and congenital disabilities in future generations. Environmental impact. Radiation pollution can have detrimental effects on wildlife and ecosystem. Ecosystem disruption. Radiation can affect species population and biodiversity, altering food webs and habitat quality. Bioaccumulation. Radioactive materials can accumulate in plants and animals, leading to higher exposure levels up the food chain. Soil and water contamination. Pollution can result in long-lasting contamination of soils and waterways, making areas unsafe for agriculture and drinking. Preventing and mitigating radiation pollution. Efforts to combat radiation pollution encompass regulation and technology with public awareness. Regulation and policy. Governments and international organizations such as International Atomic Energy Agency play a critical role in establishing regulatory frameworks to manage radiation exposure. This includes setting safety standards for nuclear plants, monitoring environmental radiation levels, and enforcing stringent waste disposal guidelines. Notable technologies. Advanced monitoring. Enhanced detection and monitoring technologies can help identify radiation sources more swiftly and efficiently. Containment systems. Innovation in containment and shielding materials have improved the safety of nuclear facilities. Renewable energy. Transition to renewable energy sources like solar, wind, and hydro can reduce reliance on nuclear power and its associated risk. Public awareness and education. Bolstering public understanding of radiation and its sources is crucial for proactive safety measures. Educational initiatives can foster community engagement and encourage responsible practices, particularly in areas prone to natural radiation exposure, such as radon testing in homes. Conclusion. So, the radiation pollution represents a complex challenge that necessitates multifaceted approach involving regulation, technological advancement, and public education. As we continue to explore the potential of nuclear energy and other technologies, striking a balance between advancement and safety will be a paramount to be ensure sustainable and a safe future.